Hi, we are on the second video for section 8.4. On this one, it is sports and leisure. If the radius of the semicircular ends of the track in the figure are 32 meters, how long must each straightaway be to make a 400-meter track? Use pi equals 3.14. So you want to look at this track and see that we have half a circle, a semicircle on both ends. I'm trying to draw this straight through here. I can't seem to hit the middle. Okay. Geez. I'm going to call that good. And so the radius is 32, but we also have a semicircle on the other end. So that means we have a total of one full circle. And we're talking about circumference here because it's the length of the track. So we're going to find the circumference of the circle. I'm going to use pi times the diameter, and in this case our diameter is going to be 64 meters because we just double or times 2 on the 32 meters. So pi is going to be 3.14 in this case times 64. When we multiply that out, we get 200.96 meters. And then we have to figure out, okay, so how do I do these straight parts? Well, there's two of them, and it's asking how long must each straightaway be? And that means we have two of them to take out of this 400. All right, so we're going to take 400, subtract the 296, that's the length of the two ends. This isn't, I don't think this is very well drawn to scale, but you know, most of them aren't. And then we're going to divide by 2. And that ends up being 199.04, and divide that by 2, 99.52 meters. So each straightaway will be 99.52. And that is what we were looking for. Okay, let's go to this next one. Machine trades. In the piece of steel shown in the figure, 4.5-inch diameter holes are drilled in a 22-inch diameter circular plate. Find the area remaining. We're using 3.14 for pi, and we're rounding to the nearest whole number. All right, so nearest whole number, pi 3.14. So what we have to do here is find the area of the entire circle, and then we're going to subtract the small circles. So area is going to be pi times the radius squared for the big circle. Okay, I just need to scoot that down a little bit. Let me write out big circle so I have the space there. Pi times the radius squared for the bigger circle, and then we're going to subtract the small circles. And I'm going to go ahead and put in that we're subtracting 4 of them. So we're going to have 4 times pi r squared. Now, they gave us, we could use the diameter formula, but I really prefer this one. And so radius of 11 inches because it's half of 22. And then we also have a radius for our small circle, 4.5 divided by 2. So we're going to have 2.25 inches for the small circles. Now we're just going to substitute in our numbers. So pi times the 11 squared for the big circle, 4 times pi, because there's 4 cutout circles, 4 times pi times 2.25 squared, and then calculate. So you always can just pause at the beginning of each problem and see if you can work them out, set them up, you know, find your formulas and everything, so you're trying this out on your own. So 379.94, and we're going to subtract 63.585. I usually just go out to a decimal place that doesn't have to be rounded, so the next number is going to be 4 or below, so I didn't have to round anything to get to there. When I subtract, I get 316.355, and then that rounds to 316, and that would be square inches because we are talking about area. All right, so that's the rest of that problem. And next. So next we're going to talk about metalworking. This says that carpenters, plumbers, sheet metal workers, and other trades often work with parts of circles. A common problem is to determine the length of a piece of material that contains both curved and straight segments. When you look at this, you can see that it's curved, and this is a quarter turn, what I'm going to call a quarter turn, because it turns, it's kind of like a 90-degree angle, as you can see, right? It's a quarter turn at an angle that's going to be a fourth of a circle. So that's what I'm talking about when I say a quarter turn. We're going to be using circumference for this part, and then we have the straight parts of 8 and 6. I might have circled a little bit of the straight parts, but that's okay. We know that our straight length, this is always the easy part, so don't mess that up, right? The straight length is 8 inches and 6 inches, so we know we have 14 inches on part of this, and then we have to figure out the number of inches for the part that is curved. All right, so the next part of this says, what is happening? I was trying to advance my page that has numbers on my other computer. Now, this is kind of an important part of this. When a rod is bent, the material on the outside of the curve is stretched, the material on the inside is compressed. We must calculate the circumference for the curved section from a neutral line midway between the inside and outside radius. I call that the midline. So you can see that right here. That's the midline of this piece of metal. Okay. The curved section is a quarter of a full circle, so the length of the bar needed is this. We basically just take the formula for circumference and divide it by 4 because it's 1/4 of a circle. Also, this piece of metal is 1 inch wide, so to the midline that would be in half of an inch. So we take the 2 inches and add a 1/2 inch for our new radius. We can't use this one, right? Don't use that one. You have to go ahead and figure out what is the length of this when it goes to the middle of this piece of metal. All right, so circumference is going to be 2 times pi times 2.5. We divide that by 4 because it's a quarter turn. Remember, quarter of a circle. And we get 3.92699. We add that to the 14, right? And we end up with about 17.9 inches. Now I went ahead and rounded that once I add them together. You could probably round it, a little bit more than I did in the first place. All right. Here's another one. Find the length of stock needed to create the shape, round to the nearest tenth. So when you take a look at this, I think you can see it's 3/4 of a circle. I'll write that out. 3/4 of a circle right here. And then we're going to calculate that with circumference. The circumference is pi times the diameter, or 2 times, 2 times pi times the radius, and then we're also going to say times 3/4. All right, so 3/4 of a circle for this one. We don't have any straight lengths on this, and so we just go with this. Radius is going to be the radius given, that is to the inside of the metal, and it's a 1/2 inch thick. So we're going to add half of that to the midline, right? It's going to go right through the center. I can't really draw in the center of that thing, it's so small. So right in the center of that thing is going to be a 1/4 inch in. So we will add 0.25, and then our radius is 6.75 inches, and we can just calculate with that. Now you could go ahead and find your diameter if you'd rather use pi times the diameter. It really doesn't matter. Okay, so we have 2 times pi times 6.75 times our 3/4, so I'm going to say 0.75, and then we just have a calculation to do. All right, and once you calculate that, you see that we get a length of 31.8 inches, and that is rounded some. I don't have my number before that written out, times pi. Let's see. Yeah, so it had a bunch of numbers after that. There was a 0 after the 8, so that was an easy one to round. And then we've got our total length of this piece of stock. And when they're talking about stock, they're talking about some sort of a metal piece. Sometimes they will talk about it in for electrical, for conduit. And then that's going to be it. All right, I think that we'll stop the video here, and I'll pick this one up on the next video. Bye, everyone.